Hey, this is Brandon. You're watching a series where I solve every daily and then I get it on one line. So I've actually been slacking. I gotta go back and do yesterday's daily and the day before. I didn't make a video for that, so I'll quickly go through those. One reason for that is that I think all these are quite simple. Not really gonna look at this one too much, but you want to check that I guess they're the same length. And then this is a little trick. If you say like S is in T plus T, so let's say T plus T is like ASDFGH, and S is like GHASDF. So we know that these are rotated because it's short enough. You can just be like, all right, we'll rotate it there, you know? But what you can do is say, all right, well, where's the pivot point? Here we want to say it's at index 2. So one thing you could do is try every pivot point, 2, 3, all these. You could say maybe it was HASDFG. Or what you could do is just say, take this, copy it, have it at the end again, and now every rotation of this is going to be in here somewhere because like ASDFGH is there, SDFGHA, DF, blah, 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 all the way up to HASDFG. And then I guess it'll do the first one again. So that's pretty much that. You just say S and T plus T. And you could do it the other way too. It's important to say like this is a completely symmetrical problem. Like it doesn't really matter S and T or S and goal. So this would work too. You could get the time complexity better. You could use KMP. Right now, this is going to compare every substring of S plus S. So if we have this again or whatever, like something like this, you got to compare the length of S through all of these. So this is really like O of N times M. But if you used KMP or string hashing, you could get this down to just O of N or O of M. But I don't want to do that because this is pretty elegant. String compression 3. This seems like another group by. What happens if you have, so here, A9, or 9A, 5A, 2B. So if you had 18 A's, then it would be 9A, 9A, 2B. Yeah. And if you had another one, it would be 9A, 9A, 1A, 2B. Yeah. Okay. Well, it's going to be 9A repeated this over the length of that grouper object over 9 times, and then blank A, where blank is this percent 9. So for example, here you would say, okay, well, there's 19 A's. So 19 over 9 with integer division is 2. So you're going to have two 9A's, and then you would say 19% 9 is 1, like the modulo of 19 and 9 is 1. So then you would add that. You would need something to be like, if it was 18, then you don't want to say 9A, 9A, 0A, but I think it would be that simple. Okay, so S is going to be, or I'll say L is going to be something, and then return blank dot join L. And I'm going to change the word to S so that it's less characters. L is going to be group by S. Okay. Is there an easy way to do this without a lambda? That's the big question here. Because if I use a single lambda, it's not that hard. I could say something like, say list map something lambda x. So it's going to be the group by tuple. And then it'll be, I think I'll say G colon equals length of x at 1. All I care about is that length. It's never going to be 0, so it's never going to evaluate to false. So I can say and safely there, and this will always go through. So it's 9 of the character plus G% 9 of the character. Those are the two terms we're dealing with, and then there's going to be G over 9 of these. It's not G% 9 of these, it's times G% 9 of these, but like Boolean G% 9 of these. Just like make sure that it's not 0. If it's 0, then we don't include this term. Otherwise, include 1 of this term. And then I need to watch out because G% 9 is going to return an integer, and I want this to be a string. So I guess I'll just say that is fine. Is this shorter than str? They're the same length, so this is fine. Probably that. I probably have to like consolidate. Yeah, there we go. How easy will it be to get rid of this lambda? If I could find a way to have an f string constructor as a partial, like if I could say lambda c f this whole thing, something like that, that would be doable with a partial. But I would need a function to operate as this lambda. which I don't think is going to happen. No, maybe. Maybe I could just fit a bunch of partial adds together. Is that worth it? If this all fits literally on one line in the editor, then I'm going to say it's good enough. Yeah, this is fine. Nice. One to go. This is me in the future. So you're about to see me type out this extremely confusing code, but I realized while editing this, there's a way simpler solution. So if you're actually trying to figure out the solution, this is probably what you would want to do. The observation is like at any point, if there's ever two elements that are in these like blocks of two that are different, then that one of those has to be changed no matter what. So we can just say something that's like a return sum x doesn't equal y for x and y in pairwise s, but it's every other square because we don't want to compare like the first index to the second index. It's just the 0th to the first, the second to the third, the fourth to the fifth, and so on. We have to make pairwise a list because it's an iterable and it won't support slicing like that. There we go. So if we get this to not have list comprehension, as that is my enemy, it's not too bad. I can say map all of this to a, if I just had the same thing, it would be lambda x and y, except I can't do that because the x and y pairwise, the lambda function isn't going to unpack that. So I could say x at 0 doesn't equal x at 1. So if we get rid of the lambda, it shouldn't be that hard. We're just comparing the 0th element to the first element. So I should be able to say something like star map equals to each of these, but this will check that they are the same, and I wanted to check that they're not the same. So it's probably going to be something like n over 2 minus this. There it is. Still incredibly slow. Just had to interject with that one. Is the length of s always even? Yes. So you pretty much always have to change the last character. So if you had like 1001100110011, you have to change all of these. You have to shift everything over by 1. So I think really what it would be is there would be sort of a prefix sum quality to it. Yeah, where what you would really be saying is like, okay, change this 1 to a 0. That costs you 1. And then this is going to cost you 2. And then 3, and then 4, and then 5, and then 6, and then 7. So I think if we separated these into separate terms, like in a group by, you would say, okay, that's index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7. You could maintain like a previous thing. That might be the way to do this. What I'm trying to figure out is there a way to aggregate the number of consecutive swaps you have to make? Because you could just maintain a previous, like if you swapped this 1 to a 0, and let's say there was 3 zeros here, then you would say, well, the previous was a swap, so now this is not a swap. Or what you could do is you could take a, not a reduce, but an accumulate. You could accumulate a function over this, and what the accumulate would do is instead of like adding some number, you would take the XOR of a number. You would take the XOR of whether the length of this grouper object is 1 or odd or whether it's even. And then you would take the sum of all of the odd ones. Does that make any sense? You would start out with this and you would say, okay, this index is odd, this index is even, this index is even, this index is even. Let's add the period, even and odd. It's supposed to be a 1 there, or a 0 there. Then you would need to say, what the fuck am I talking about? You would need to say all of these are part of this. They would get a prefix XOR with the odd value of the first index. So they would all be turned to odd, and then you would get a prefix XOR here, and you would say this gets turned to even, aka nothing has to happen here. Unlike the rest of these, when you do the prefix XOR, it would look like this. And what that would reflect is like you would have to say, okay, change this 1 to a 0, change this 0 to a 1, to a 0, to a 1, to a 0, to a 1, to a 0. And the moment you change this to a 0, you have an even length set of zeros there. Okay, I think that's what it is. And you could do something fancy with a reduce, but I think what I'm going to do instead is a sum of an accumulate. So I'll just say accumulate equals list accumulate something, return sum accumulate. For now, I'll just say that. And I guess I think what I'm going to do is I'm going to get the lengths of each of these. If I go back to the zeros and the one and all this, if I go back to like the original state that I've been like looking at, I'm going to get the lengths of each of these. That's the first step. So I guess I'll say first things first, x equals map. I'm going to be really explicit here, although I wouldn't do this if I was just doing it on my own. Int s. So now they're actually ones and zeros. Group by is going to be map item getter 1 x group by x. So now this is going to be like you have an iterator of this many zeros, an iterator of this many ones. The actual whether something is a 1 or a 0 completely doesn't matter. There's a symmetry around that. Like 1 0 0 1 is going to be the exact same thing as 0 1 1 0. So I don't really care about that. What I care about is getting that list of, okay, there's a 1. Okay, there's 2 zeros. Okay, there's a 1. And then I care about the length of that. So I'll say L equals map length group by. So now what this is going to look like is a 1 and then a 2 and then a 1. And then what I'm going to say is accumulate. What I care about is whether each number is even or odd. So here 1, 2, 1. I only care about whether that's even or odd. Those might as well just be 1, 0, and 1. Similarly here, this is kind of the same as like 1, 0, 0, 0, 0, 0, 1 in terms of their lengths. So here, if I say XOR is the function, I think XOR is what it is, and I say accumulate L, XOR, and then print, let's say accumulate, it's going to return some weird bogus answer. Okay, I don't want map length. I got to cast these to a list before I get their length. So we can see I get 1, 3, and 2, and it's saying what this really is, and I'll say print L. It's going to say 1, 2, and 1 probably. Not worth getting into why I did that, but it's saying, okay, you have a length of 1, you have a length of 2, and then you have a length of 1. So if I take the accumulate of this, if I just have the default of the sum, it'll be 1, 3, and then 4. So it's saying you have 1 total length, and then you have 3 total length, and then you have 4 total length. But if I take the accumulate with regard to XOR, then it'll be cumulatively XORing everything. So 1 XOR 2 is 3, 3 XOR 1 is 2. And the idea here is now I have a way to say, should I shift this by 1 or not? What I want to do is just extract the information of whether each number is odd or even. So 1, 3, 2, the way I can do that is I can say map partial something. I'm going to map something to accumulate to get that information of what's odd or what's even. And what partial does is it takes a function as an input. So let's say and what that means, if you say like, what does it mean to call and on every element? Like it doesn't really mean anything to just say and of x. You want and of x and y. So what partial does is it says, you give me a function and give me a parameter to that function, and I will give you this partial function where when you call it on something, that first input is already inputted. So we'll say just like take the and of everything in accumulate with 1. And when you say like and 1 with something, you're checking like, is it odd or is it even? I think it's and underscore. Yeah. And there we go. A lot of math behind that one. I'm actually really curious. Does this just work? Yeah, that's kind of cool. It's incredibly slow. And it's not that it's O of n squared. It's that you're iterating through like once, twice, 3 times, and then you're even filling these with a list. So it's not the most efficient. We can get rid of some of that by saying, all right, we'll just have accumulate, map length to GP. We need to map each of these to a list. We need to map that to a length. That's fine. That's fine. That's fine. Okay, so if we start to Matryoshka doll these up, now instead of group by X, we're just saying group by map int S. That takes care of that. And now if we're saying GB is this whole thing, and then we're mapping this to GB, then do that. So that takes care of that. And then if we're saying L is this whole thing, I mean, this is why it's like, there's not a whole lot of complicated logic here because we're only using each variable name once on each line. So it actually works out really cleanly. And then we can just sub in accumulate for this. And then finally, we can just sub in res for that. Boop. There we go. I'm weirded out that the memory is so good. That should not be the case, but whatever. So what it's doing is it's saying get the group by of S. So organize these by distinct substrings. So we got 2 zeros, a 1, and so on. All of this is saying get the length of those substrings. So we've translated S from this into 1 and then 2 and then 1, or 1 and then 1, or just 4. And then from there, take the accumulated XOR of each of these, check what's even and odd, translate it into even and odd values, and then return the number of accumulated odd values, which sort of equates to the offset. So again, if we have 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, or let's even say that, you would say, okay, this is odd. When we accumulate it, this is now odd, which means we basically have to do that. When you accumulate it here, this is now kind of odd, this substring. This is now odd, so we have to push it down the line. This is now odd. But then when we get here, we would say, well, now this 0, 0 is even. And then this 1, 1 is also even, and we don't have to change anything. So it's sort of like the number of changes you have to make that propagates through from previous changes, or potentially here, like this was the 0, 0, 0, or it stops propagating through. That's equivalent to the prefix XOR and just checking what's even and odd. And the final thing I can do that will probably get this all in one line is an interesting little trick. So if we have a function that's like 1, 7, 8, 9, 4, 5, something like that, and we want to do our whole like prefix XOR thing to tell like, okay, when we take the prefix odd even values, what's going to come up as odd, what's going to come up as even. What we're going to do is say, okay, well, 1 is odd, 7 is now odd, so now we're to even, we've swapped. 8 is even, so we're at even. 9 is odd, so we've swapped back to 1. 4 is even, so we're at 1, and then 5 is odd, so we're at 0. So this is what we're eventually going to get, and if we had some S that had like 1, 1, 7 zeros, 8 ones, 9 zeros, whatever, our answer would eventually be 3. And we've translated here sort of like what's the prefix parity, aka like odd even quality of each of these elements. But if you think about it, like one way to get that is to say, okay, you start with 1, you XOR that with 7, so you're going to get 6. Now you're to even. You XOR 6 with 8, you're going to get 14. You're still at even. You XOR 14 with 9, you're going to get 7. And that's odd. You get 1, right? You XOR 7 with 4, you're going to get 3. That's odd. You get 1. You XOR 3 with 5, you're going to get 6. And that's even. So that's one way to get this, and that's what this code is doing. But another way to get this, and I'll even keep this like to compare, another way to get this is to say just add them. Because you only care when you're saying and 1, you only care about the first bit. So you can just say, just add them. So 1 plus 7 is 8, 8 plus 8 is 16, 16 plus 9 is 25, 25 plus 4 is 29, 29 plus 5 is 34. And we can see the odd even pairing of this is exactly the same. Because if you're only looking at the first bit of some big number, it turns out like whether you're XORing the two numbers or you're adding them, it's the same for the very first bit. It's the same process of like a 1 and a 1 makes a 0, a 1 and a 0 makes a 1, a 0 and a 0 makes a 0. So because of that, we don't actually care to say XOR all of these. We can just say by default add all of these. And that gets it on one line. So there it is. That's the last 3 days. Pretty simple, but kind of fun for each of them, not gonna lie. Thanks for watching.